Okay, guys, so welcome to our lesson on upper and lower bounds. In this lesson, we're going to basically explore how to determine the different possible values that a measurement can have when it's been rounded. So this is really important in understanding the precision of data and the accuracy of numbers as well. Okay, this lesson is going to be a bit shorter and there will be some guided practice on some harder questions as well. So let's start with this. A number has been rounded to the nearest whole number. So what's the smallest and largest that the number could have been? Well, it's been rounded to the nearest whole number. So the smallest number that it could have been would be 4.5. And then the largest number it could have been would be 5.5. But 5.5 isn't included. So anything smaller, like 5.4999. Okay. Now here we've got another example. Again, this is more of like a real world application. The Empire State Building is 443 meters tall to the nearest meter. Okay, what's the smallest and largest number that it could have been? So the smallest number it could have been, if let's position 443 in here on the number line, the smallest number would be 442.5, and the largest number would be 443.5. So the way that I can write this is that x is greater than or equal to 442.5, but less than 443.5. Okay, so that is just how you could write it. Now next, let's have a look at this example. So the spaghetti can travel 800 meters to the nearest 10 meters in 4.4 seconds to 1 decimal place. So calculate the upper and lower bounds of the maximum speed. Okay, so first of all, we know that speed is equal to distance divided by time. Now, to find the upper bound for speed, we would want the highest number for distance, so the upper bound for distance, and then the lower bound for time. Okay, so for time, we want the lower bound. So the upper bound would be 805, and the lower bound would be 4.35. Okay, so let's put this in our calculator. 805, which is the upper bound for the distance, because distance is rounded to the nearest 10 meters, and 4.4, so we can round that to 4.35. So that's the lower bound. So that would give me for the upper bound 185.06. Okay. Now the lower bound is going to be the lower bound for distance divided by the upper bound, because that will get us the lowest possible value. So 795 divided by 4.45. Okay, so that's going to give me, so 795 divided by 4.45, that gets me 178.65. Okay, so now that's my lower bound, that's my upper bound. So we could write this as, and obviously don't forget to round it to the three significant figures. You can write this as the speed is greater than or equal to 179, which is 178.65, rounded up to three significant figures, and then the upper bound is 185. Okay, That's how you would go about that question. Okay. Now I want you guys to pause the video and have a go, and then we're just going to do some going through of them in a bit. Okay, so hopefully you've tried it. Here, Steve measured the length and width of a rectangle. He measured the length to be 645 millimeters, correct to the nearest 5 millimeters, and the width to be 400 millimeters, correct to the nearest 5 millimeters. So you want the lower bound for the area. So here, you're going to find the lower bound for both of them. Now, 645 has been rounded correct to the nearest 5 millimeters. So the lower bound is going to be 642.5. And for the lower bound for the width is going to be 397.5. So we're going to times this together, which is going to give us 255,393. Okay, which to three significant figures is 255,000. Now pause the video and have a go at this. Okay, so this is a very similar example to the one that we did with the spaghetti. But here it's distance over the fuel used. And you want to work out the value of C to a suitable degree of accuracy. And here you're not really asked to find upper and lower bounds as such. So it can be a bit trickier, this question. So here what we're going to do is we're still going to work out upper bound and lower bound using the same method that we did for the spaghetti question. So for the upper bound, we want the upper bound of D divided by the lower bound of F. And then for lower bound, the lower bound of D and the upper bound of F. But we're going to realize that they're both rounding to 3.6. So that's my suitable degree of accuracy. Okay, so this is not as explicit in terms of what they're asking us, but it is a bounds question. Okay, this is our last question. Again, this is very tricky, and again, they're not very clear that it's a bounds question, but we know now that it is an upper and lower bound question. So pause the video and have a go at this. Okay, so here, again, we're going to work out the upper and lower bound of each of these. And then we're going to round them to three significant figures, because in three significant figures, they are the same. Okay, so have a go and look through the working out here and see if you can figure it out how to do it. If not, we will definitely go through it in our group class. Okay, guys, so today I also want to introduce you to two ebooks that I've written. So these are virtual, they're not actual books. One of them is just on revision tips and different resources that you can use to help you with both GCSE Maths and Physics. And another one is the approach that I use. So definitely have a look at this. I will also link it in the description. But yeah, definitely have a look at the way to go about your revision, because sometimes we can be revising so much and make no progress. Okay, so if you didn't understand anything, as usual, write down the questions that we can go through in our group sessions, and then try the questions in this section to consolidate upper and lower bounds. And next lesson, we're going to be having a go at functions. So thank you for listening, and I'll see you next lesson.